Okay, so what I'm going to do is record this lecture for the guys that aren't here, but also so that you can have access to it too at home. I fell asleep Friday morning, and yet there's a test a week from today on this chapter, so maybe I better look at it again. So the video will probably only run about 20 minutes. I'll upload it as a YouTube, and you can look at it on your class page, and it'll be all the stuff that we're talking about today. Okay? So first of all, go to your book. Lesson 2 is all this function stuff with graphs, right? So yesterday we were looking at tables and formulas. I'll wait until Monday to answer questions on 1 and 2. This is lesson 2, page 129. So there's a little story about Descartes. You might remember him as a philosopher, Descartes. Cogito ergo sum. Any Latin scholars in here? Nobody. I think, therefore I am. I think, therefore I am. So that was his famous quote. He was a philosopher more than a mathematician. There's a little story here about Rene Descartes. There's a lot of legends that go along with this. One was that he was lying in his bed and he looked up at the ceiling and he saw a grid and he envisioned numbers, spiders on the grid. I mean, sort of a little mystic thing, right? But yeah, he thought of the idea of numbers, actually only positive numbers, but being able to locate where the spider was depending on a pair of numbers. So he was the guy that invented coordinate geometry, and we call this the Cartesian, after Descartes, the Cartesian plane. And of course, you did it in Algebra 1, Algebra 2, geometry. The Cartesian plane, it's the idea of analytic geometry. We're trying to put geometry figures with numbers, okay? So, again, you can read a little story there. Perpendicular lines. Now, there are some terms here that are italicized. So this is on the next page, page 130, right? You see x-axis and y-axis. These are lines. You also see the word origin. None of these are new words. That would be the origin, not the orgy. Right? See, that's a different thing, right? Okay. So where the two axes intersect is the origin. And the other thing that you just should know in high school, this is called an axis. If you have two of them, it's called axes. Okay, so you change the spelling when you pluralize it, like radius and radii. Okay, so when you look at the next page, they talk about the idea of coordinates. Coordinates are numbers that go with points. So, you know, here's a point sitting in the plane, and in the second picture you can see that it's above the 3 on the x, and it's to the right of the 2 on the y. So we're going to use those numbers as its coordinates. So we're going to do 3, 2, and we always put the x number first. So the 3 would go first, and then the 2 would go second. Right? But you know how to do this, I trust. So whatever the first number is, you go that direction. In the x-axis, positive is to the right, negative is to the left, and the same thing with the y's, positive up, and negative down. Okay, so you can locate points. The pair of points, it's given a name called the coordinates. You should know that. And they're always written in parentheses. If you don't write them in parentheses, it's wrong. So if you said that this was 3, 2, I have to mark that wrong. Okay, so always in parentheses, like that. Okay, so x coordinate, y coordinate. And then there's other examples on the next page. So look there. This one didn't scan as clearly as I thought. Hopefully this will come out better on the computer. Sometimes a smartboard, you don't see it all that great. Okay, so a couple of points to note, and you're going to get some practice doing this in just a minute. The origin is 0, 0. Okay, so no in the X and no in the Y. If you're in the first quadrant over here, this is quadrant 1, both the X and the Y are going to be positive numbers. So like the one we saw before was 2, 3. So you could go 2, or was it 3, 2? I forget. It was 3, 2. Okay. So if you're trying to find that, you go 1, 2, 3, and then 1, 2, and that would be a point in the first quadrant where both the X and the Y are positive numbers. If you're in the second quadrant, and yes, I do want you to know these terms. We always use Roman numerals for quadrant numbers. We never use the Arabic numerals. So don't say, you know, if you say this is quadrant 1 and this is quadrant 2, I have to mark that wrong because it's not denoted that way. It's Roman numerals 1, Roman numerals 2. Okay. And in the second quadrant, the X is always going to be negative and the Y is always going to be positive. So here's an example of a point, and the coordinates are there on the page, negative 4, 7. Okay. So negative 4, which means you're going this way to the left 4, and then 7 up, and just count the boxes. Third quadrant, Roman numeral 3. And in the third quadrant, both the X and the Y are negative numbers. So you're going left and down. And the example of the point here is negative 6, negative 5. And again, do the X first. So it's 6 to the left and then 5 down. And the fourth quadrant, my red pen's not working, so I'll go back to green. Ivy. Anybody know why the Ivy League's called the Ivy League? It's a football thing, right? Take a wild guess. I'll give you a hint. There were originally only 4 schools in it. There you go. Okay. Now it's much larger than that. I think there's 8 or 9, but yeah, originally 4. And the coordinates here are positive and negative. So X is positive going that way. For example, positive 8, negative 3, and then down. Okay. You can have points that are on the axis, and they are not in a quadrant. So this example up here is not in quadrant 1, it's not in quadrant 2, because the first number is not a positive number, it's 0. Now the second number happens to be positive, that's okay. But remember, first quadrant, you have to have 2 positives, and 0 is not positive. 0 is not positive or negative. So occasionally you'll end up with points on the axes. They're not in a quadrant. I don't think this book talks about it. They're actually given this term quadrantal, Q-U-A-D-R. Quadrantal point, which is sort of counterintuitive. You see the word quad, you think it's on the quadrant, but it's not in the quadrant, it's on the axis. Okay, so on axis. Okay, and that's it. So there's not any new material other than this. I want you to spend a little bit of time working this by yourself, and then I'll give you about 3 minutes to do that. It's for these 10 problems, and then we'll agree on the answers. So let me go ahead and pause this right now. Go ahead and answer. Okay, so you've played with these for 2 or 3 minutes. Elena, number 1. C is right. Okay, so this is 4 over 1, 2, 3, 4. Do that first, and then 3 up C. Good. Michael, number 2. B is in Barfield Owens. So 3 over 1, 2, 3, and then 4 up 1, 2, 3, 4. So good. B. Okay, so here C. C is, or sorry, 3 is L. So negative 3, 4. Negative 3, 4. I don't agree. Whoops. L. Hang on. Negative 3, positive 4. Yeah, you're right. So L. Good. All right. Yep. So negative 3, that direction, and then 4 up. Good. Okay, Michael. Let me write all these guys down here. This was L. Number 4, Mike. Say again. E. This is 4 and -3. 1, 2, 3, 4, and then down. Good. So that's E. No problem there. 5, Riley. I. So -4 and 3. Don't agree with. Okay, yeah, because if you look at this guy, this has negative in the x direction, which is -4, and then 3 in the positive direction, which is up. So that would go to K. If you're saying I, then they would both be negative because it's in the third quadrant, right? Sir. Okay, so it just didn't scan very well on here. Thank you. So again, let me go look at the computer screen and see if this actually came out on here. Sometimes it doesn't. Yeah, it does show on the computer screen. So if you're looking in your book, this is a -4. It just didn't scan very well. It's not showing up on the smartboard. Okay, but thanks for that heads up. Okay, so 3 is -3, -4, which means we've got to take this guy away. So -3, -4, that was yours, Riley, right? That was yours. Okay, so that is H, yes? Good. Okay, now where do we leave off? Diana, number 6. Say again? D. So 5 in the x direction and 0 in the y direction. That's D. Good. By the way, what kind of point is that? Did you write it down? That would be a perfect bonus question called a quadrantal point because it's not in a quadrant, right? D is quadrantal. Now, the nice thing about having this recorded is you can go back and look at it, you know, in a 20-minute video, and you have all those terms sitting there. You go, oh, he may ask that. Especially he said that may be a bonus question. Okay, 7, Marcos. J, so -5, 0. You're over here, -5, 0, so that's good. And then by process of elimination, Logan, the last one has to be A. Well, I guess it's not process of elimination because we've got that one, that one, that one, and that one that we haven't, and that one that we haven't talked about yet, right? So 0, 5 is A. Good call there. So that's also quadrantal. 0 in the x direction and just 5 up, that's A. Okay, now these are sort of interesting. So these questions here, the next two, which point on the circle has the same x coordinate as C? So at this stage you have to find where C is, and you're looking for a point on the circle, obviously a labeled point, that has the same x coordinate. So here's C, and the same x coordinate would be which one? E, down here. Okay, so this x coordinate is 4, the y coordinate is 3. If we go straight below it, this also has 4, but now it's -3. Okay, so E would be the point that has the same x coordinates and the same y coordinates as H. We find H, which is right here. Okay, and the same y coordinate would be F. Okay, so again, just look at the coordinates of this. H is -3, -4. So we're looking for another point at -4, and that's right there. You just go straight across. And this one has +3, -4, same y coordinate. So good. Okay, so those are nice little problems, just trying to figure out which points go where. Okay. Turn the page, 132. Now, if you look at 132, the first graph, they actually give a name for it. We are not going to be doing conic sections, so if that was your fear from Algebra 2, you can relax. No, we're not going to be doing conic sections in the way that you did them in algebra. In fact, there's no equation here, right? But it does say that this curve is part of something called a hyperbola. And then the directions are, write the coordinates of each letter point on the hyperbola. For example, the coordinates of point A, way over here, are 8, 6. So go ahead and do B, C, D, E, and F. And again, I'll pause this briefly. Okay, so you spent a little bit of time doing that. We can just run around the room again. Elena, B, 4, 5. Michael, C. Barfield Owens, we're just going C. 2, 4. D, Zaire. 0, 2. E, Michael. Don't agree. So for this one, you said 0, -1, which would actually be this guy right here. So it is -1, 0. When you're thinking, especially for these quadrantial points, you have to remember that the x coordinate comes first. So in this case, you're going to the left, and then you're going 0. Okay, so if you're dyslexic and you get the numbers turned around, you know, up here this could have been 5, 4 instead of 4, 5. So just make sure you do the left, right first. Okay, and Riley, -2, -4. I agree with -2, -4. Okay. The parabola is the next curve that they give you. It's called a parabola. Again, you'll see the words. No, we're not going to be looking at the fancy equations and vertex and axis of symmetry and all the stuff that you might do in Algebra 2. We're just going to be looking at the curve and, again, write the coordinates of each lettered point. So once again, I'll pause this. And we're back. Where did we leave off? Was it Riley, Marcos, Logan? A? Yeah. Okay, how about G? I've got them both in blue for a reason. You said this was 7, 2. What's G? -5, 2. What do you notice about these two pairs of coordinates? Well, I don't know. The points really aren't parallel. Look at the numbers. Well, what do you notice about the numbers that you gave me? -5, 2, 7, 2. Are any of the numbers the same? Okay, look at these two numbers, look at these two numbers. Are any of those numbers the same? Yes, which one? The y coordinate. Okay, so they have the same y coordinate. And in fact, all the points on this line will have the same y coordinate. So it doesn't matter where you are. If you were here, this would be 0, 2. If you were out here, this might be 10, 2. Every point on that horizontal line has a y coordinate of 2. And in fact, when we get into, you know, looking at equations, the equation of this line is y is 2. It's all the points that have a y coordinate of 2. Okay, Marcos, B, and F. 5, -3. -3, -3. And if I were to draw this line, could you tell me what's true about all the points on that line? Okay, for which coordinate? So if I wanted the equation of that line, it would be, you just said the y's are -3, right? Y equals -3, there you are. So horizontal lines have equations y equals. Okay, this is y is equal to 2 up here, y equals -3. Okay, so C and E, Elena. 3, -6, in parentheses, and E. And the horizontal line that connects those two has an equation of? Right. Simple. All horizontal lines have equations y equals something. Now, one of the things that's really wonky about this, and this drives algebra students crazy and drives teachers crazy as well, here's the x-axis. What is the equation of the x-axis? Take a guess. X equals. Okay, so let's put some points on here. This is obviously 0, 0. This one looks like it's supposed to be 6, 0. This one over here is -4, 0. Okay, now look at the points that I've got. Do you see anything in common across the way? 0 for which one? So what's the equation of the x-axis? Y is equal to 0. It's sort of counterintuitive. Wait, it's the x-axis. It's supposed to be x to something. It's not. It's y. Y is 0 is the equation of the x-axis. What do you suppose the equation of the y-axis would be if you needed it? X is equal to 0. Right. If you just looked at a bunch of points, this one has 0, 2. This is 0, 0. You know, if you were down here, this might be 0, -7. And all these points have x is equal to 0. Now, doesn't that drive you crazy if you were an algebra student? The equation of the x-axis is y is 0. The equation of the y-axis is x is 0. Okay. And I guess we didn't do D, so I'll do that. D is what? 1, -7. Was that it? Yep. Okay. The next set of problems talk about the folium of Descartes. And you're supposed to try to draw that. They gave you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. You're supposed to draw a graph, connect them with a smooth curve, and you end up with this. So this is the Wikipedia page. So let me just go there first. This is the Wikipedia page on the folium of Descartes, named after René Descartes, the guy that invented coordinate geometry. Turn off the light so you can see it a little bit better. It's sort of like a loop-de-loop, right? So it comes over here, and it's right, it gets really close to this dash line. The green curve is the folium of Descartes. It has some crazy equation. No, we're not going to be doing equations. This is not an algebra class. For your task, what you needed to do was to try to generate this curve by plotting those points. Okay, so when you plot the points, and again, let's see if we can, the first one was -5, -5. It doesn't show up on this. This one stops at -3. So you'd have to get a big enough piece of graph paper. Read the directions, please. It does say extending from -8 to 8 on each axis. So when you do that, you want to get all the way out here to -8 to 8 on the x-axis, and the same thing up here, -8 to 8. And then go ahead and plot the points, and then connect them in the order given. Go from A to B to C to D. And you might suspect that it's going to look something like this, where it goes around. And it's going to have that sort of loop-de-loop shape that the Wikipedia page says this thing looks like. Okay? So a little loop-de-loop. Notice it passes through the origin. Folium of Descartes. Do you need to remember the name? No. It's an exercise in plotting points. That's all it is. Okay. Set 2, I'm going to let you do tonight. Actually, you can start it now. That way you don't have anything to do tonight. A function can be pictured with a graph by using pairs of numbers. For example, this table. This is a function from table. It has the points 1, 3, 2, 5, 3, 7, 4, 9, and they're all plotted. Okay. On graph paper, draw and label 6 pairs of axes as shown in the figure below. Well, that's this. Okay, so 6 pairs of axes that shows this particular graph. So here's 5. There's nothing up here. So 5 to 15. There's the end of the axis right there. You see the y. Okay, so 5 to 15. You need 6 pairs of axes, and then you're going to be plotting all these points. So you got 6 problems to do. Actually, yeah, 6. So A, B, C, D, E, and then the F is on the next page. So you're going to do those 6, and then they have a series of questions. So for which of the functions you're going to be using the letters, right? So A, B, C, D, E, and F. These answers, all of these guys, will be one of those 6 letters. So which functions do the points lie in a straight line? Some of them will lie in a straight line, some will be in a curve. For which functions do the y numbers form an arithmetic sequence? So this is going back to the previous chapter, right? Arithmetic sequence for the y numbers. For which functions do the y numbers form a geometric sequence? So you're going to be looking at the y numbers. Now they're sitting right here, right? So is this an arithmetic sequence? Yes or no? 4, 5, 6, 7, 8. Yes. How do you know? Say again? Yeah, you add 1. So what's that called? Yes, but what is the one that you're adding called? A common difference, right? There's a common difference of 1. Are these an arithmetic sequence? Yes. What's the common difference? -1. Is this an arithmetic sequence? Yes, it is. What's the common difference? 0. Is this an arithmetic sequence? No, it's not, right? 1, 2, 4, 8, that's a binary sequence, right? So geometric. Is this arithmetic? Yeah, 3, 6, 9 there. A common difference is 3. Is this one geometric? Well, again, you would probably check the differences. So here the difference is -6. Here the difference is -2. It's not geometric. It's not arithmetic, right? Might be geometric. So those are the questions that you're asked over here. Which functions are increasing? What does increasing mean? Going up. And decreasing means? Going down. Okay, so with a horizontal line, oh, golly day, I don't know how old I was. Must have been middle school, somewhere along the way. I was confused. I'm easily confused. I did not know the difference between horizontal and vertical, right? And then somebody said, what do you see when you look out at the beach and the sun is rising up? What do you call that line where the sun hits the water? Oh, that's the horizon. Horizontal. So horizontal, like the x-axis. Okay. For which function does each pair add up to 7? So, again, you're just looking at the ones that you've drawn. For which function does each pair of coordinates multiply to give 12? For which function is each y coordinate 3 more than the corresponding x coordinate? I think we could probably guess that one right there. It's right here. 3 more? No. 3 more? 3 more? This one. This is 3 more than the x coordinate. Right? The y coordinates were 3 more than the x. So as you go through these, and again, you've got 10 minutes or so, you can play with these over the weekend. I'll go ahead and stop the video here and then upload this. So it's 27 minutes, which is more